Welcome back. We're making quick progress through our today's speakers, and it's my pleasure to welcome the next speaker of Quality Forge, Martin Mitrevski. Martin is the Director of Engineering at Stream, a company that empowers teams with APIs and SDKs to build in-app chats, videos, and feeds. As the Director of Engineering at Stream, he is responsible for the tech behind the experience of over 1 billion end users globally. In addition to his engineering work, Martin is published author, active open source contributor, and, as he is with us here today, occasional conference speaker. Today, Martin will be talking about test and video SDKs at scale.
This should be really interesting because so many apps we use nowadays have an integrated chat or video feature. I mean, half the apps on my phone have that now.
Only half? I feel
Probably
like much more.
I don't know where I'd be without some of the functionality in these. Everything we use uses these features. Everything I have and talk to my friends with has some built-in feature like that.
Yes, plus, video experience is so crucial, especially since pandemic. This would be very nice to hear one of the probably most experienced people and from such an industry giant as Stream.
Yeah, should be incredible. So today, Martin will be talking about testing video SDKs at scale. Hello, Martin.
Hello, Martin.
Hello, hi everyone, how's it going?
We're doing good. Thank you for coming and joining us today. It should be really exciting, but you are the expert on the topic, so we will hand over the stage and we are eagerly listening.
Yeah, thank you. Hi everyone, I'm Martin, and today I'm going to be talking about testing video SDKs at scale. First, short intro. I'm coming from this beautiful place called Ohrid in Macedonia. I'm working as a director of engineering at Stream, and you can find me on all social media like X, GitHub, LinkedIn, and I also have a website. The place I worked at is Stream, and we built SDKs for chat, video, and activity feeds, and we are available across many platforms like iOS, Android, React, and so on. And our reach is over 1 billion end users. So as it was mentioned, like most apps nowadays have some kind of social element like video, chat, or feeds. And basically, if you use apps like Patreon or Strava, you are probably already using us without knowing. Today I will be talking about our video product specifically and how we are basically testing it. And first, a little context on our general architecture, just to get an idea. So basically, in order to establish a video call between two people, like for example, Alice and Bob, we have kind of like a global edge network of something we call SFUs or selective forwarding units. And based on your location, you connect to the nearest SFU via a protocol called WebRTC, invented by Google. And then the other user on the other side could be also the other side of the world, connects to a different SFU and communicates the same way. And these SFUs just pass the data in between. So in a nutshell, in a very simplistic way, that's how our video product works. And then if we go a bit deeper into both the server side and the SDKs as a complete engineering experience, it's kind of like a very interesting engineering challenge because you have to deal with a lot of low-level stuff like data races, async primitives, passing bytes from one place to another. Then you need to consider some different codecs and how they work together. Then you have, very loud live streams where you need to take care of a lot of events and throttling. So in general, it's if you're a geek, this is kind of like the geek's dream because it's very interesting as an engineering challenge. But then when the fun ends, we have the real world, and video in general is also very complex to work at scale. And the reason for this is that it's dependent on many things that are outside our control. So first we have edge cases in terms of devices. So especially on Android devices, everyone has their own forks of the Android operating system. All the browsers are implementing the WebRTC protocol with some subtle changes, and this kind of makes it difficult to have like a working solution for everything. Then you have things like OS level quirks, like for example, CallKit on iOS. It interferes with the audio session, so you have like real phone calls and then the phone calls that go via WebRTC, and then they kind of like sometimes conflict with each other, and that's one group of challenges. Then we have network issues. So I don't know if you're driving in a car or a train and you have a call, and then the network changes. You might switch from from one Wi-Fi to another. Let's say you're moving from one place in the office to the other. Or, for example, you have firewalls in some organizations. So we had that with hospitals. They put some restrictions on some ports and they block us, and we can't establish video calls. And in general, like differences between platforms. So not only the same platform, but differences between iOS, Android, React, and then we also have desktop, like Make-apps, and then you have different technologies for the same thing, like Flutter, React Native. So in general, there are a lot of challenges, which means that we need to be like very thorough in our testing. And we, from engineering perspective, we do like the standard things. So first we write a lot of unit tests. We have like very high test coverage. Then we write some integration tests where we see how components, like different components, work with each other. Then we also offer UI components that customers can directly integrate in their apps. And for those, in order to ensure consistency, we write snapshot tests. Then we also have like end-to-end tests. Then on every PR we run smoke checks. And then we do like performance tests to make sure that things are kind of like behaving like they should under some heavy loads. And then the last type of testing we do is manual dog fooding. So we use our app. We are a very remote friendly company, and any calls that we have, we use our app. So this is how like one PR check looks like, and you can see here that there are a bunch of checks that need to finish in order to have like a merge into our code base. So we do like whether the size changes, whether the tests are succeeding, and we have different types of tests. So it's a long process to make sure that things are predictable. Then I've mentioned performance tests. And here, basically what we do for bigger customers like Patreon, so there are people on Patreon that stream for a lot of users. And here what we do is do some benchmarks and see how much we need to allocate like shards and how much computing capacity for these events. So that's on the server side, but then also on the mobile side, like on this picture, when you join a live stream, you have kind of like a lot of join events at the same time and then leave events at the same time. So this can put pressure on the mobile app. And we need to do things like smart throttling, not request everyone's track at the same time, do some kind of optimizations. And we also test that in kind of like a systematic manner to basically have like a very predictable experience on these big events, because the stakes are really high on in those situations. And then we have like dog fooding, as I've mentioned. So all calls, look, this is this picture I took from yesterday with one of our teams. And we use it. So this is, for example, on an iPad. So we use on all platforms. Like we even screen share from iPads, and we use our product daily. And that's how we find issues like smaller tweaks or things like that. Because if you don't use your product, then why would others use it? And now the question is this enough? And of course, it's not because of the challenges that I've mentioned. So you have like many different devices and many different combinations, and then you have those network quality issues that I've mentioned. Then you also have things like calls between users on different locations, and it depends. Like we are in one location, or I don't know, in several locations across Europe. But then you have, I don't know, people in India using the product, people in the US, and so on. So it's kind of like really complex to test all these things for a company that's mostly like engineering heavy. So we have some small testing capacity in-house, but not as big to handle all these cases. So how do we solve this? Of course, we introduce TestDevLab. So we found them as kind of like the leader in testing video and audio solutions. And the way where they might help us here was more like simulate those diverse network conditions where you have like changing the bandwidth of the network, the packet loss, and so on. And then have kind of like like a standardized way of measuring things, what is good and what is bad. And for us, it was like if you see pixels, you say like, oh, video is bad. And is that enough? We needed more like quantifiable metric in order to measure that. Then, especially for Android, we don't have that many devices. So we are like, we have some devices, but we don't have, some very old. Usually, engineers have the latest phones and mostly iPhones. And for us, it's always working well. But then when it goes into production, like users are having different kinds of devices. So our pool of devices was not that large. And then we wanted like to be objectively compared to the best ones. So with Google Meet, so we wanted to have like comparison on how we fare in terms of video quality, and that's best if it's done from the outside. So that's why we decided to go with TestDevLab, and yeah, plus they organized this great conference. So yeah, that was a bonus. So yeah, then we discussed about the testing plan and what do we need. And as I've mentioned, like there were several problems that we encountered in the initial stages of the product usage. And those were like the wide range of Android devices, and it's not only that, but also the different combinations between those. So I don't know, when low-end device on Android can have a different codec with, I don't know, Firefox browser. And in order to have that codec negotiation, in some cases, we didn't cover all those codec negotiations. And for some of the users, there was black video. So what we needed is kind of like go through all these different combinations. I think it was 496 combinations in total that would do all these iOS, Android, mobile browser, macOS browser, and Windows, and do like a systematic analysis of what works and what's the quality and so on. And that was one thing. And then the other was, changing it under different conditions. So users are usually having calls somewhere, not usually at work. And for that, we needed like different network conditions. And that's also kind of like a lot of work to set up for us. And TestDevLab helped us with that. And the other last part was simulating distant calls. So I don't know what happens if I'm in Macedonia and then I'm selected, for example, an SFU in New York, and how would that affect the experience and things like this. And then I want to introduce the MOS score, which is kind of like the metric for perceived quality of audio and video. And this is more like how a human would see it. And the scores here are from 1 to 5, where the practical upper bound is like 4.5 because the human eye can't perceive the exact same video that was being played. And kind of like anything above 4 is a great quality. So here is more like a visual example of that. And you can see like 1, there is no video at all. So it's the worst it can happen. And then like you still see like 2 is kind of like pretty horrible quality. And then from 3 it starts, like kind of like bad quality, maybe going to decent, but not good enough. And then if you see like 4 and 4.5, the video is really great. And 475 is kind of like if you just copy paste the original audio. And yeah, that's kind of like the MOS score, and we will be using it a lot here to express our results. And yeah, then we started testing. And for Android, we did first one compatibility testing because of the, as I've mentioned, the very big like a variety of devices that are here. And for example, if Samsung has its own fork, then other providers have their own implementation of the Android platform. And what we did were just like 2-minute calls, like compatibility calls, where one initiator is like the receiver is the Mac, and then the test device joins, and then you switch after 1 minute to the back camera, test functionality of audio elements. So basically, it's kind of like a compatibility test to make sure that the video even appears. And we used kind of like 12 different devices. And here it's interesting. So for example, we didn't know, so the blue one is the audio MOS value, and the red one is the video MOS value. And for example, I didn't even know that this device exists, LG something K22, and we had really bad audio on that one. And the video was actually quite decent. And of course, with Pixel, like our experience was pretty good because it uses like Google's version of the Android operating system. And you can see like some were around 4, some were around 3.5, and there were a few that were really bad. So this is kind of like the summary of the audio. And what we found out here was that noise cancellation, so we have noise cancellation. It also introduced issues on some of the devices, so especially in letters like S, Z, or C. And it also hinted that we should revisit our noise cancellation implementation. Then for video, kind of like in a similar manner, like the modern devices, like Pixel again had the best video. This Vivo also didn't know that it exists even. Had some audio issues, but the camera was pretty solid. And there were some freezes after contrast changes or camera switching. So in general, we got some feedback that we could take home and kind of like work on things for improving our Android SDK. And then our next step was network tests. And here, as testers, this is like a very useful tool. It's called Network Link Conditioner, and it's available on iOS devices. This is a screenshot from an iPad. And what you can do with this is basically you can create your custom profile, and here you can specify things like how much bandwidth you want to have, like maximum, how much packet loss in percentage. Um, you can specify different protocols, and then you can use this as a, like a tethering network, and then the other device could join, and basically you simulate these network conditions. So what we did was we had like 6-minute calls, and the sender was like the one who was sending video was in a unlimited Wi-Fi network, while the receiver was connected to the hotspot of this iOS device with the network link conditioner. And then that one was also set at uncapped at the beginning, and then we gradually like reduced the available bandwidth and also the packet loss afterwards. And we did the same thing for both video and audio, and for packet loss and for bandwidth. And both devices had like they were pointed out towards dynamic media source, basically a desktop with some video. And this was done for both Google Meet and Stream. And we basically compared them on the exact way. So what were the testing results as a summary? And then we'll go through, like numbers and graphs just to get an idea what we measure. So in general, on uncapped networks, stream video quality was on a similar level to Google Meet. And on the uncapped bandwidths, in some cases was even better. But on lower bandwidths or like higher packet loss, Google Meet adjusted better. So we'll see some numbers, but in general, like when the network becomes really bad, Google Meet is kind of like turning off video, so it gives up on video. And we were trying to support both. And it's kind of like you try to support both, but you don't have enough bandwidth, and both of them are bad. So we didn't really focus on one thing. And it kind of produced worse results for both video and audio, while Google Meet still had like a decent audio. And here is another MOS example. So this is like with the real data, and Google Meet is the first row and Stream Video is the second one. And you can see here combinations like Chrome, Firefox, and in general, you can see like the numbers are similar, and like in some cases, actually on this screenshot, in all of those, Stream has a bit higher grades for the most value. But then if we go like into real numbers, and this is like an example for iOS and for audio MOS score, you will see like the first one, everything is very green over 4, and this is for audio, and then for 1 megabit per second, it's still kind of like green, but lower values. But then you go like, I think kind of like 250 kilobits per second. You see that Google Meet has higher scores, and 100 kilobits, like the difference is obvious. So you can still have some calls on Google Meet, but not on Stream Video. And this is how the graph would look like, with to see like how the lines go. So Stream is of course the blue one, and Google Meet is the yellow one. And you can see like at the beginning, the higher one is the blue, and then the yellow goes a bit higher. So kind of similar results also with the packet loss change. Again, at the beginning, we have kind of similar scores, in some cases better than Google Meet, but then as the network becomes bad, Google Meet is a bit better. And this is again similar graph just for packet loss for audio, and the same one for videos. I wouldn't go into much details here, but in general, the numbers were very consistent across platforms and across different network conditions. And then what we did was simulate SFU location tests. And since the testing was done in Latvia, like if both users are, so basically we can simulate different locations. So that's how this was tested. And if both of them were in Latvia, you can see that the video loading time for both devices is pretty like quick. While if you go like one in Latvia and the other one in New York, while you are still in Latvia, then there is a lot of, like round trip that the bytes would need to have like as a trip. And you can see like the video loading time is much larger, and we did like different combinations and just wanted to see like how bad would it be if, for example, we don't have a server in some location and the user is trying to connect from there. And yeah, as a conclusion, we had like pretty solid parity with Google Meet, but we still had room for improvement on poor networks. And what we did after that was we brought this back to the engineering team, and we implemented things like automatic video track pausing, which similarly to Google Meet will prioritize audio on very low networks, and video would kind of like not be available. We also have rewritten our bandwidth estimation algorithm, so we know better like how much bandwidth is going to be available. We improved our noise cancellation, and we also did some bug fixes that were found during the process. And of course, I want to give a shout out to the people who actually helped us do this. So the testing part, we were more like, customers, but Nikolai and Arturs really did a great job in this. It was very easy to work with them. And I mean, it's a huge amount of work to do all these tests. And it gave us like really good picture of what we can improve in terms of our video quality, and we basically applied those improvements, and now our video is a lot better. I also dropped here some references, like you can see our docs. We also dropped like a blog post yesterday that discusses these same things. It's linked here. And yeah, that would be it. Thank you for your attention. And do you have any questions?
First of all, Martin, thank you. Thank you very much for this deep dive into video testing. I especially appreciate the real life examples and visual examples. Yes, we do have questions, but before that, we would also like specifically appreciate your shout out to TestDevLab and to our conference as well. It was very, very nice to hear and see.
Our AV team was listening.
Yeah.
Yeah.
Yes, but we have
Well
time
deserved, yeah.
for maybe one question, so I will jump right into that.
Yeah.
Has AI changed how video testing is happening? As you know, video testing is one of the domains where many people still desperately need this human touch of testing to pick up on the edge cases.
Yeah. Well, for us, like at Stream, it kind of like the coding tools improved a lot the tests that we write, so the number of tests, so it's easier and faster to write tests to consider all the edge cases, because usually you would spend a lot of time on those tests, and now it's faster and it allows us to write more tests. So as Stream, this is kind of like the biggest benefit of AI. While in general for video testing, I believe so. TestDevLab used a bit of AI. So Arthurs was explaining to me that they had some markers in the video, and based on those markers, they kind of like more smartly computed the frames per second, and this was not done manual. because otherwise it's like too many tests. So I believe in those cases there is potential to automate things and basically have some automatic way of computing the quality. Yeah.
Thank you. That was a really good answer. But I do believe that is all the time we have. I'm very disappointed because we had a lot of interesting questions, and you are doing a great job of hyping up our AV team, which is incredible. So thank you so much for that.
Yeah, thank you. Yeah, thank you for having me.
And thank you for joining us.